magnitude of the vector, what I've labeled here as R500. It's the moment arm, it's a vector from my pivot point to where the force is applied. And my question was, what is the magnitude of that vector?
That's what we're trying to find, right?
Yeah, X. Times the magnitude of the force. Yep. Times the sine of the angle between them. So when I'm finding the angle, I put them tail to tail. So I've got R going in this direction, and I have 500 going down this way. What is that angle? What is that angle?
30.
Thank you. What is this angle?
90.
So, back to my first question, what is that angle? Yes? Now, 120 degrees, sine of 120 degrees is a positive number. We now have to worry about the direction of the torque. So if this is my pivot point and I'm pushing down with this 500 Newton force, which way is it going to try to make, which way would it make the ladder spin? Just imagine we simplified the ladder down to, I've got a pivot point here and I'm pushing down like that. Would it spin clockwise or counterclockwise?
Clockwise.
So therefore the direction of the vector is right hand rule.
Be negative?
It would be negative into the board. Amy, did you say something?
I said to the right, but I think that's wrong.
Sorry.
Oh, my answer was wrong.
Oh, okay. So, again, pivot point right here is trying to spin it clockwise, thumb points into the board, which is negative. Negative. Now the next one. I know it's going to be negative because it's pointing in the same direction as the 500 on the same side. The 200 is also trying to make it spin clockwise. What is the magnitude of my radial vector, or my movement arm? Okay, so I got 5. The magnitude of the force?
200.
Times the sine of, well, should be the same thing, 120 degrees. And then finally, the last one. What is the size of my moment arm for the last force?
meters.
Yep. Size of the force? Times the sine of, what is the angle between them? So I've got this movement arm going in that direction right there. I got my force going in this direction right here. There's my force, there's my movement arm. And I need to figure out that angle. Degrees. Yep. Equals 0. And that's the problem we're working with. sine of 120 degrees is 0.5. So this is negative 250x minus 500 plus whatever that is.
Almost 2,800.
2,800. No. You assumed that the sine was 0.5? 150 degrees, not the 120.
I got 2,800 for that too.
Yeah, the sine of 150
Oh, these are wrong. That's my issue. Alright, so 2,800. Alright, then back over here. Sine of 120 times 500.
433.012.
0.012?
3.
013?
Yeah.
X minus this. That's what point there.
Negative 866.025.
Yeah, that was a mistake on my part. Alright. I apologize. So we're now down to an algebra problem, or pre-algebra problem, whenever you first start doing x's. So 433.013x is equal to negative 2,800. Oh, that's actually negative right there. So let's redo that. The first one is negative. So bring that over to the other side. So 433.013x, and then over here we have 1933.975, I think. So x is equal to 1933.975 divided by 433.013.
So 4.466?
466?
Yeah.
I got the same thing.
You got the same thing?
Yep.
Alright, units?
That's
Meters.
Yeah, it's a distance. So when he's almost in the middle of the ladder will start to slip, assuming that he is walking very carefully. Now, if he's running up that ladder, then at that point, if he's running up the ladder, the normal force and his weight are not anywhere close to equal, because he's pushing off on the ladder as he's moving on to the next rung. And so, it would slip sooner. Questions? I'm gonna ask some follow-up questions, but any questions on what we have here? If we had a value of x that was negative, what would that have meant?
The ladder wouldn't slip. The ladder wouldn't slip.
The opposite.
The ladder would slip sooner.
It would slip before he even stepped on it. And we could have arranged that, because if the coefficient of friction were smaller, this number would have been smaller, which would have made this number smaller, and as long as ultimately this had dropped below that in magnitude, we would have gotten a negative answer, and it would start slipping before he steps on it. Suppose we had a value of x that was more than 10 meters.
Then it wouldn't slip.
There we go. No matter how far up he went. Sorry to catch you when
No, you
you're
didn't.
drinking. Now, this is very similar to the lab, the part D, I think it is, when you add an angle to it. Except you have these two forces acting up, and then you'll have various forces acting down, I guess, wherever you happen to put them. Now, we don't have the convenience of eliminating two torques. Well, actually, I tell you where to put your axis of rotation, so that eliminates that thinking. But it's very similar to this, where once you have the angle, then, you know, you have to figure out what theta is gonna be in each of those cases. Well, it'll be the same angle for those three acting down, and the same, and a different, but same angle for these two. Let's see, so put 9 and 10 together. So let's make master set 9 and 10 due on the 22nd. Master set 9 and 10 is one master set. Just covers both chapters. All right, questions before we start a new chapter?